Hello, everyone. Thank you for tuning in. My name is Tiburcio Asua Jr. Today, we're going to talk about my project for Architecture 461p, natural ventilation. Huge shout out to my professor, Omar Youssef, for guiding me through this project. And ultimately, this is going to be about how to make your home more energy efficient, as well as how to maximize its potential to cool itself through natural ventilation. So let's get right into it. Basically, these were my goals for this project. I wanted to use natural ventilation over a mechanical system because natural ventilation is passive, which means that it may not require as much energy and money. Secondly, I wanted to create a comfortable microclimate because this allows cooler temperatures, which means the airflow coming into your home will now be much cooler and therefore will passively be important to the ventilation. Third, I wanted to be able to save money, essentially create a more energy efficient home that didn't have to rely on a mechanical system. So this is my data. I use Tucson, Arizona as my location, even though most of these projects are constructed in Rio Rico, Arizona. For obvious reasons, I wasn't able to acquire data for such a small town. So we're gonna go off of Tucson, given that they have very similar climates. So in this top left image, you can see this is a wind chart. Basically during March, April, and October, November, you see these influxes of wind. This is because these seasons are changing, so this is very important to consider. Also in the top middle image, you can see the solar radiation chart for Arizona. This is essentially when you see the most amount of sun. For those of you that don't know, Arizona is sunniest between June and September. And so this leads to the final chart, the psychrometric chart down here. A psychrometric chart essentially allows you to find what methods and strategies would be possible given your temperature, your humidity, and things like that. So in this circumstance, we will be using two-stage evaporative cooling as well as natural ventilation cooling. This is a wind wheel. This essentially tells you the direction of your wind as well as the speed and temperature. Very important things to consider when you're trying to create natural ventilation in your home. And so windward is going to be the southeast. That means that your wind is going to be directly hitting your home from the southeast, the windward side. The opposite side of that is going to be the leeward side, known as northwest in this case. So for this assignment, I decided to use the Pueblo Model. This is a home that is being currently constructed for over the last 20 years. And so this home has slowly been evolving in its structural and energy capacity. As you can see, it's about 1,488 square feet. So it's a fairly average sized home for Rio Rico, Arizona. And so because it's quite popular, it's worth investing more research and trying to understand how to make this home more energy efficient and sustainable. These are the elevations for the home. Essentially, the south is going to be the front side of the home. The north is going to be the back side, and the east and west are going to be the left and the right sides. So here you can kind of see the sizes of windows that we are currently implementing in this home. This is a 2018 model version, so a fairly recent version of this plan. This is in Rio Rico, Arizona in the early 2000s. So you can see here the home is quite simple. Older style of windows. You see here where the roof meets the exterior wall, there's an overhang. And so over the years, we have made this home much more aerodynamic, made changes such as tile roof, larger, more energy efficient windows, and overall just really adapted the aesthetics and the design style of the home to appeal to the public. This third image represents what a typical Modelo Puebla would look like today. You can see a few more subtle details and changes and things like that. So this is kind of what you would expect in 2020. Now I'm going to briefly talk about the construction phase and how we avoid infiltration. So infiltration is essentially when you lose energy through cracks in your walls, in your doors, in your windows. And so the goal of an energy efficient home is to create a tight seal. This will allow you to maintain your cooler temperatures and not avoid losing that precious energy. So here on this first image on the left, you can see this home is in the foam and chicken wire stage. And then in the second image on the right, you can see that it's in the stucco stage. So then the first thing that we do is we apply a rubber flashing membrane to the exterior of the window. This helps prevent humidity as well as that infiltration from air. The next thing we do is we apply polyurethane foam sealing on the inside of the window in order, again, to create a tighter seal and overall just improve efficiency. We also apply this same material to the bottom portion of the envelope walls, the exterior walls. And so you can see that this can be applied to almost any joint and therefore creating a tighter seal. We also use recycled insulation, so that is also very important to consider, just given that your home is made with eco-friendly materials. Now I'm going to go into a little bit more detail into the envelope wall setup. As I mentioned, an envelope wall are the exterior walls of your home. So these are the walls that directly come into contact with the natural environment. And so here's what we have is what you call a weep screed. This is a metal plate that is around your home on the bottom portion. So essentially you have your plywood, your weep screed, your weathered paper and chicken wire, your foam, your stucco, and your paint. This weep screed does a couple of things, but I'm going to basically explain that on the next portion. So here you have your ground, you have your concrete foundation, you have your base, and then you have your 2x6 stud as your framing, your wall essentially. Then we like to use 1/2-inch OSB sheeting. This is a little bit thicker than your standard size, but again, improves efficiency. And something we like to do is we like to mount our wall directly flush with our foundation because this ends up creating a tighter seal. So when we introduce our weep screed, notice that we place it in a very critical point right at this corner joint. And so this allows maximum sealing potential. After this weep screed, we apply the weather paper and after that, your foam, after that, your stucco, and then after that, your paint. This is the architectural plans that I used to develop the model and the project. And so you can kind of see here, 1488 square feet. Garage is about 483 square feet. So this is, again, like I mentioned earlier, a pretty average home, pretty simple, entry level, something typical and standard. So this can be a model or a representation for the strategies that I'm going to explain further. This is the plan view of the same house, but using a different software called Google SketchUp, which allows me to model this home. The top right corner is the master bedroom. The master bathroom is right next door. Then you have your bedroom 1, your bedroom 2, your hall bath, your living area, your dining area and kitchen, your garage, your back porch, and then your front porch. So I'm going to be focusing on the living area because these are the areas we want to naturally ventilate and cool. These are the windows and these are the doorways. Back here you can see a sliding door, and then in the front entrance, the front door has what we like to call a opening. So you can see who's here. You can open that peephole and kind of allow more airflow into your home. Now, this is going to be the prediction for what I think the airflow will behave inside the home. This is my prediction with the doors open. And also you can see here these purple swirls. These are eddies. Essentially, these are going to be areas where the exterior wind is going to create these really swirly zones of air, and we want to eliminate these. These are not important for natural ventilation because they actually create issues. So now this is my data. I used a mobile app, and so this allowed me to see how the home is interacting with the wind from the southeast. You can see here that there is a little issue on the bottom right corner. There seems to be wind getting stuck in that corner, as well as you can notice the eddy on the left and on the top right that I mentioned and predicted earlier. Now this is the results for the interior of the home with the doors and windows open. So here you can really see how the wind is now entering the home and how the airflow interacts with the walls. You can see that most of the airflow is going down through the living area, the kitchen area, and so these are going to be very critical spots because they are much more open, meaning that there's much more volume and therefore our pressure is lower. So these are going to be very critical to cool. This is the interior with adaptations. Essentially here what I did is I placed 2 trees in front of the home in order to see how that would interact with the walls and just how we can create what you call a Venturi effect. That is essentially a funnel that you can see here in the front of the home between the 2 trees. So this Venturi effect allows you to force more air into the home naturally through the trees, and this could be very useful. These are some of the images from the same app, and here I'm just trying to understand how the home is interacting with the wind, with the front porch, with the trees, and really just trying to understand the aerodynamics of the home. Now, this is the Google SketchUp model that I created of the Modelo Puebla. It's a fairly simple version, and so here you can see the model with these adaptations. These are native trees and native vegetation, so very critical components that actually help your home by providing shade, and in this case, natural ventilation as well. So here you can see, again, down the middle, a natural Venturi effect, how these 2 trees are going to funnel air into your home, as well as block some air on the left side in order to reduce or even eliminate that eddy in the corner. Also, you can see on the right, I incorporated a palm tree so that this would allow air to more naturally funnel itself into the window. Here again, you can see a vertical Venturi effect where the wind will come in below the tree, over the vegetation, and essentially funnel itself into the window. This can be very crucial in the summer climate, especially because if you open your windows at night, this allows the heat to become released, and therefore you cool your home at night passively. Allows you to save lots of energy and lots of money. This is an architectural plan of the mechanical system. I wanted to create a system that was passive, that didn't have to rely on this mechanical system, so I'm going to get into that now. This is iteration number 2. So this would be what I propose, the evolution of the Modelo Puebla. Essentially what I did here is I moved the 2 bedrooms on the right downward. So this did a couple of things. First, it made a solid front face, which is more aerodynamic. Secondly, it created a hallway down the middle, which is going to be a crucial aspect for another implementation that I'm going to talk about soon. This is my results for the same iteration number 2. And here I'm just trying to, again, understand how the home interacts with the wind, given open doors, open windows, and the trees and things like that. So this is my passive feature that I decided to incorporate because there is now a hallway down the middle of the home. Essentially, I decided to incorporate an internal cooling tower. A cooling tower, for those of you that may not know, is a tower that incorporates padding that usually involves water. So the idea is hot air comes into the tower and slowly is cooled through each layer of the pads and ultimately is exhausted out as cooler temperature. And so this, of course, can help in very hot, arid regions. It's a Middle Eastern design principle, so that's something to consider, especially because you can use it between May and September. So I'm going to explain a little bit about how this cooling tower works and the philosophy behind it, because it does not require any mechanical parts or electricity to operate. So as you can see here in the middle section on the roof, I incorporated 2 skylight vents. These would preferably be electronically controlled so that you can exhaust and vent heat from your home at any point that you wish. So also something to consider is there's this large wall that separates the living area from the dining area. And so I added 2 openings in order to allow more cross ventilation. This is very important because since it is such a large open space, cooling these spaces will be much easier. So then this is how the cooling tower and the entire system in general would operate to really facilitate the natural ventilation and energy efficiency of the home. The idea goes as followed. You will want to open your skylight vents in order to release hot air because hot air rises. So as the hot air is being exhausted through these vents, the pressure inside the home is going to change, and therefore that's going to create a natural vacuum. This natural vacuum will want to restabilize itself, therefore it will want to pull in more air into the home. Given that the windows will be all closed, the only entrance for this vacuum will be through the cooling tower. So as mentioned, hot air will come in through the cooling tower, will slowly be cooled through the pads, and will be slowly released into the home. This is a passive feature. It does not require electricity or a mechanical system to operate. However, if you decide to open up your windows, that is also going to be just as beneficial. Here you can see, given the arrows, the red hot air, the purple temperate air, the vegetation is going to slow down the air and create a cooling feature known as transpiration. Because vegetation is humid, this will allow the air to then become cooler as it enters the living spaces of the home. This is now just some images of the home with these features. Keep in mind a few things. The height of the vegetation. It's very important to consider this because this vegetation can be used to funnel air into your windows, into your cooling tower vent, as you can see in the top left image. And so this can be very important. Also, you can take some of these principles and apply them to your own home. You will want to place a very large tree on your southwest side of your home if you're in the northern hemisphere. But ultimately, this is a really good example of some little techniques and strategies that you can use in your home to make it more energy efficient in general by creating shade, creating a microclimate around the home, and ultimately also giving back to the ecosystem by providing plants that produce flowers, vegetation for species in your area and things like that. So applying vegetation that maybe needs very minimal maintenance is very important and should be considered. And so this will conclude my presentation. I really want to thank you for being here and learning the process of what it takes to make a home more sustainable, more energy efficient. And ultimately, as I mentioned, this would be a proposed evolution for the Modelo Puebla. And so if you have any questions or any comments, please feel free to leave them down below in the comment section. I'm currently a student at the University of Arizona studying sustainable built environments. So please feel free to check out my website. It has to do with more projects like this that save energy and ultimately create more comfortable outdoor environments. I'm going to leave all my socials below, and if you want to check out anything that I have to offer, please do so. Thank you for your time, and hope you guys have a great rest of your day and great rest of your week. Thank you. T-Blue signing out.